Okay. Here you have 8x squared divided by x cube plus 2 the whole cube. So let's do the substitution part. Now among these, this is the bigger thing. So we can take let x cube plus 2 be equal to say m. So we get 3x squared dx is equal to dm. But we need 8x squared. So you multiply both sides by 8 and divide by 3. So you get 8x squared dx is equal to 8 dm. And then we take the 3 down, 8 by 3 dm. Hence when we substitute over here, what do we get? So suppose the integral is I, we get 8x squared dm. 8x squared dx, instead of that we can write 8 by 3 dm, which is 8 by 3 dm 1 upon m cube. So this is going to be 8 by 3 into m raised to minus 3 dm, integral of m raised to minus 3, which is nothing but 8 by 3 into m raised to minus 3 plus 1 upon minus 3 plus 1 plus k, which is going to be 8 by 3 into m raised to minus 2 upon minus 2, which is going to be minus 4 by 3 upon m square, which is nothing but x cube plus 2 the whole square plus k. So it's going to be minus 4 by 3 into x cube plus 2 the whole square, or rather minus 4 by 3 into x cube plus 2 raised to minus 2 plus c. So it's going to be option number B. That's it. Yes. Okay, fine. Now here you are being asked to evaluate dx upon root x square plus a square. How can we do that? So we can, again, we'll take we can take in this case, it's root x square plus a square. We'll take it as t minus x. For convenience sake, we take it as root x square plus a square as t minus x. This means that root x square plus a square plus x is equal to t. This we shall remember because we need to substitute this somewhere. Okay. Now hence we take the derivative on both sides. So we get derivative of x is 1. This is dt. Derivative of this, if you remember, we first take the derivative of this, which is nothing but 1 upon 2 root x square plus a square, because it is x square plus a square raised to half. So half into x square plus a square raised to half minus 1. Then composite function derivative of x square is 2x. This gets cancelled into dx. So eventually this will become x plus root x square plus a square upon root x square plus a square dx is equal to dt. So here, hence this is now we need to substitute. We know x plus root x square plus a square is nothing but t, and dx upon root x square plus a square. So we have t into dx upon root x square plus a square is equal to dt. So therefore this means dx upon root x square plus a square is nothing but dt by t. Now you integrate both sides, so we get dx upon root x square plus a square is equal to integral of dt by t. Now this is what is back to our question. This is what value we need to find. So now this is going to be nothing but log t plus k. Now t is nothing but log of x plus root x square plus a square plus b. So ultimately dx upon root x square plus a square is nothing but log x plus root x square plus a square plus k. So this is a special type of substitution where you don't just take this as t. If you take just this as t, you will not be able to get the corresponding values, and hence it becomes very complicated. Hence we take root of x square plus a square as t minus x, so that you end up getting that you have t is equal to this. Then you take the derivative, and hence you will end up getting dx upon root x square plus a square. This is substituted as t. Now dx upon root x square plus a square. So ultimately this becomes, this part of course is t, which we have written over here, upon dx upon root x square plus a square is dt. We rearrange it. Now we have got dx upon root x square plus a square is dt by t, but this is the value whose integral we need to find. So it's integral of dx upon root x square plus a square, which is nothing but this. Later on, we will be using this formula as a standard formula in special substitution problems. Okay, so hence we have log of x plus root x square plus a square plus k. So it's going to be option number this, because this is going to be extended, of course. Option number B. Okay. Alright. Now we have x cube upon x square plus 1 into x cube. Now here we may have to modify the whole thing. So we can take x square plus 1 as t. So eventually you end up getting 2x dx as dt. So you get x dx as dt by 2. Now how does this get modified? So now you have x cube upon x square plus 1 the whole cube dx. Now here we can modify this way. We can write it as x square into x dx upon x square plus 1, in any case is t, so we can write it as t. Now this alone, now if you see now, but we want the whole thing in terms of t. This also becomes dt, x dx becomes dt by 2, hence half goes out upon t cube. The problem is x square. Now what do we substitute x square as? Easy to understand, that x square plus 1 is t, therefore x square is nothing but t minus 1. So we can write this as t minus 1 dt. So we may have to rearrange these things. So once again you have x cube upon x square plus 1 the whole cube. Here we take x square plus 1 as t. So you get x square is t minus 1. So you get 2x dx is dt. So x dx is dt by 2. So x dx is nothing but dt upon 2. The 2 is taken out. We are still, this is t cube. We are still stuck up with x square. Everything has to be in terms of t. We got this as tt. Now, but we know x square. Now, x square plus 1 is t. So x square is t minus 1. We may have to substitute like this. So the rest is simple. This is nothing but half of t upon t cube, which is nothing but t raised to minus 2, minus half upon 1 by t cube, that is t raised to minus 3 dt, which is nothing but half into t raised to minus 2, which is nothing but t raised to minus 1 upon minus 1, minus half into t raised to minus 3 plus 1, minus 2 upon minus 3 plus 1, minus 2. So ultimately this is going to be minus half into 1 by t, which is going to be 1 upon x square plus 1, and this is going to be minus plus half into t raised to minus 2 into half into x square plus 1 the whole square. So we need what among these? x square plus 1 the whole square. So we need to simplify this further because the answer that we have is not in this format. Maybe we can take minus half common and you get 1 upon x square plus 1 minus half into x square plus 1 the whole square. So this could be minus half into LCM is going to be 2 times x square plus 1 the whole square. So it's going to be here 2 into x square plus 1 minus 1. So it's going to be minus half and half goes out, so it's going to be 1 by 4 into 2x square plus 2 minus 1 upon x square plus 1 the whole square, which is going to be minus 1 by 4 into 2x square plus 1 upon x square plus 1 the whole square, plus constant. Of course, in all the cases we need to write the constant. I will introduce a constant because we need to simplify this further. Now, depending upon what the answer has been given, now the answer has been given in this format, hence further simplification is needed. It's mandatory, it's compulsory, otherwise we may feel that it's none of these options. So among the options you have minus 1 by 4, 2x square plus 1 upon x square plus 1 the whole square plus the constant. So it's going to be minus 1 by 4, 2x square plus 1 upon x square plus 1 the whole square plus k. Let's check the options. So you have so many, but surprisingly they have not put it a k. It's maybe a slight, they have overlooked it. It has to be k among these. So it should be, maybe all of them they have missed the k. It should have been plus k. Otherwise, or else in such cases, suppose you have 3 and the other one is none of these, it's better to opt in for none of these because there is no constant here. But in none of these, the constant has been mentioned. Among these, B is the closest. The only difference is there is no K. So we have to go in for B, which is the closest to this answer. Minus 1 by 4, 2x square plus 1 upon x square plus 1, the whole square plus K. It normally happens that sometimes due to some misprint, the constant part is missed. So in such kind of cases, you have to choose the best possible option. That is, in this case, the best possible option is B because at least the main integral part is tallying. So it has to be B. Okay, so what do we have? This is e raised to log e raised to x as well. We'll have to rewrite this question actually. It is e raised to log x to the base e divided by x plus c. Now, we are going to use the formula that e raised to log n is nothing but m itself. We have used this formula in differentiation also. E, you have, it is raised to log of some number. It is a number itself. So, for example, here, this is nothing but e raised to log x. So, it's going to be x itself. And this dx we need to find upon x dx, which is eventually dx, which is going to be x plus a constant, say k. So this looks a little tricky, but it's actually e raised to log x to the base e. So we're using the formula because e raised to log of any number is the number itself. So the log and e gets almost like nullify each other, and eventually you get m. So it's going to be x by x dx, which is going to be just 1 dx, which is nothing but x plus constant. So among these, it should be option number B. Okay. So now you have 1 upon x integral of 1 upon x into 1 plus log x, the whole square dx. We need to do this. So what do we take it as? We know that derivative of log x is going to be x. So what we do, we let 1 plus log x be equal to say t. So that means you take the derivative of 1, 0, derivative of log x is 1 by x dx is equal to dt. So we substitute this as well as this in this particular integral. So I 1 by x dx, the whole thing becomes dt into 1 upon 1 plus log x the whole square, that is t square. So eventually this is nothing but t raised to minus 1 upon minus 1 plus k. So it's going to be minus 1 by t. So it's eventually plus k, of course, minus 1 upon 1 plus log x plus k. So it's going to be minus 1 upon 1 plus log x plus constant, which is going to be this option number C. Okay. So we are going about doing all these formulae accordingly. So solve log x raised to x divided by x cubed dx. Now here what do we have? We need to simplify this log x raised to x the whole square. So it's going to be, how is it going to be? Log of, first let's simplify this expression, x raised to x the whole square divided by x cubed. Now x raised to x is nothing but x log x the whole square by x cubed. Right? So eventually this is going to be x square log x the whole square upon x cubed. This gets cancelled. So ultimately our integral I is nothing but log x the whole square upon x dx. Now what should we take as t? You're going to take 1 by x as t as log x as t. Obviously log x, because derivative of log x is nothing but 1 by x. So we can take, let log x be equal to say t. So that means 1 by x dx is equal to dt. So problem is solved. So we have log x the whole square, which is nothing but t square. 1 by x dx is nothing but dt, which is going to be t cube upon 3 plus a constant t cube, which is going to be log x the whole cube by 3 plus constant. So it's going to be 1 by 3 log x the whole cube plus c, which is option number B here. Okay. Okay. Now use method of substitution to evaluate this. This is much simpler. So we can take, in this case, the higher power t. You take it as x squared plus 4. So dt is going to be 2x dx. Therefore, x dx is nothing but dt by 2 is x dx. So our integral will hence become, instead of x dx, we can put dt upon 2. So the half goes outside, and x squared plus 4 is nothing but t. So it's going to be t raised to 5. So it's going to be half into t raised to 6 upon 6 plus k, which would be 1 by 12 t raised to 6, which is x squared plus 4 raised to 6 plus k. So it's 1 by 12 x raised to 4, the whole raised to 6 plus k. So it's option number B. Okay, so do we have it right? Yes, of course. Okay, now we have x e raised to x, okay, upon x plus 1 the whole square dx is equal to what? So, what do we do in such a case? E raised to x, we have integral is nothing but x e raised to x divided by x plus 1 the whole square dx. Now, how do we understand what do we take it as tx? Now, obviously, this has a denominator quotient. So, we could take, let e raised to x upon x plus 1, we can take it as t. So, in that case, we have e raised to x upon x plus 1, we take it as t. So by quotient rule, this becomes x plus 1 the whole square. Yes, x plus 1 the whole square. And here you have x plus 1 into d by dx of e raised to x, which is e raised to x, minus e raised to x into d by dx of x plus 1, which is nothing but 1 into dx, is equal to dt. Now therefore this eventually becomes x. So what we have done here is we have to use your own gumption. We need x plus 1 the whole square, and there is a division. And we know that once you have g of x upon f of x, the denominator has 1 degree more. So since we have x plus 1 the whole square, we can take e raised to x upon x plus 1 as t. So eventually now this becomes x e raised to x plus e raised to x minus e raised to x upon x plus 1 the whole square into dx is equal to dt. So this gets cancelled. Therefore, x e raised to x upon x plus 1 the whole square into dx itself is dt. That means ultimately this whole thing, I itself, you see, is nothing but dt. Mark these kind of questions. They are different from the other ones. So we have to use your own understanding that this is x plus 1 the whole square, and look at the options also. They may also help you to get some idea. And since it's division rule, the denominator and there is one e raised to x. Suppose there was no, so hence e raised to x has to feature in t. Okay. So now dt itself, so this is going to be just t plus k. Now it's here that we need the substitution. T is nothing but e raised to x upon x plus 1 plus k. So it's going to be e raised to x upon x plus 1 plus k. That is option number A. Okay, let's check whether it's valid. Okay, fine. Alright, here. So here you have x minus 1. Again, here this is similar to that. We can take, let e raised to x upon x itself as t. So hence we have dt is equal to, here we have x squared. So it's going to be g of x. The next is x into derivative of e raised to x, which is e raised to x, minus e raised to x into derivative of the denominator, that is 1. So eventually this is going to be taking e raised to x common. You get x minus 1 upon x squared, into dx is nothing but dt. So eventually this whole thing itself is dx. So eventually our I is nothing but dt itself, which is going to be nothing but t plus k, which is nothing but e raised to x upon x plus k. So dear friends, just mark this question in the previous one clearly, so that this is a little different from the other substitutions. So eventually it's e raised to x upon x plus k. That is option number A. Okay, right. Here now we have something much easier. We have log I, our integral is nothing but log of log x upon x dx. We know for sure that log x, derivative of log x is 1 by x. So we can take t equal to log x. So that means dx upon x, that is 1 by x dx is nothing but dt. Substituting, we go ahead and you get log of log x. Log of log x is nothing but, we have taken it as t, and dx upon x is nothing but t. If you remember the formula, I is nothing but when the derivative is log t, which we shall remember, but let's familiarize ourselves with the formula. This is going to be t log t minus t plus c. So you can take t common and you get log t minus 1 plus the constant. Now we substitute the value. T is nothing but log x into log of log x minus 1 plus the constant. So log x into log of log x minus 1. So among these, it's going to be option number C. Log x we taken to the right hand side, we taken to the left. Minus 1 plus k. Okay. Okay. Here we have evaluate e raised to x minus e raised to minus x divided by e raised to x plus e raised to minus x. How do we do the substitution over here? We can take let e raised to x plus e raised to minus x be equal to t. So taking derivative, this becomes e raised to x itself. This will become e raised to minus x upon minus 1 dx is dt. So ultimately e raised to x minus e raised to minus x dx is dt. So if you look at our integral I, it is nothing but numerator. This into dx is nothing but dt itself. Upon the substitution which we have made, e raised to x plus e raised to minus x, that is t, dt by t, which is going to be log t plus the constant. Log t is nothing but log t is e raised to x plus e raised to minus x plus constant. So which is going to be to the base e obviously. Yes, log e raised to x plus e raised to minus x plus constant plus. So it's going to be option number B. Okay. Okay.